Let's do the face detection project using OpenCV Python. Since we understand the Haar Cascade classifier is nothing but the Euler-Jones algorithm, now let us download the Euler-Jones algorithm, that is Haar Cascade classifier for face detection. What you need to do is that go to Google and type Haar Cascade classifier, OpenCV and GitHub. And you can able to find the first link here, like Haar Cascade classifier, and make sure you get this URL, that is github/opencv/opencv tree master data and the Haar Cascade classifier. So here you can see the bunch of cascade classifiers are available, which will actually do the specific task. For example, this cascade classifier will do the eye detection, and this will do the eye tree eyeglass detection and frontal cat face and so on. There are many predefined cascade classifiers are readily available. What you need to do is that just download it and write some code doing the object detection. Since our project is on the face detection, so what we're going to do is that we are going to take this cascade classifier like frontal face default and we'll download that, and using that we will do the face detection. If you understand the code of frontal face, then you can apply the same code to rest of the cascade classifier. Now let's don't waste your time and click on this frontal face default, and now click on this raw. That's it. Now you are in the particular URL. So what you can do is that just right click and click on save as and put that in your particular folder, whichever you're working on. For example, I'm working on this particular folder. So let me save that XML file in this particular folder where exactly I'm working on. And what I want to do is that let me create one folder name model. In that model, I just want to save it since I already saved that. And let me save it again with the particular name, Haar Cascade frontal face default. You can also download this frontal face default XML file even in the resources. Go to your Jupyter notebook and make sure that you have the cascade classifier in the models folder, that is Haar Cascade frontal face default. Now what I want to do is that first I will apply the cascade classifier to this image, which is faces.jpg. There you can see we have the three faces, and let's apply the cascade classifier to these three faces, and we will detect the face using that. Then we will use the real-time face detection, apply that to videos. Cool. Let's open the new Jupyter notebook and name it as project face detection. Now let's start writing our code. The first step what we need to do is that obviously we need to import the two necessary libraries, that is NumPy and CV2. Let's import that. Import NumPy as np and also import CV2. And after that, let me take some sample image img, which I'll read that, which is from the CV2 mread, and the name of the image is faces.jpg. Okay, let's display that cv2.mshow, and the window name is face and the matrix is img, and cv2.wait key of 0 and cv2.destroy all windows. Execute it. Alright, so this is what the faces what we have with us. Now let's apply the cascade classifier and let's do the face detection for this. Now, in order to apply the cascade classifier, let's first load the XML file. And what I'll do, I will name it as face cascade equal to cv2 dot, and it is the cascade classifier. And what I need to do is that I just need to provide the path of the cascade classifier. Since I know my cascade classifier is there in my model folder, and the name of the cascade classifier is Haar Cascade frontal face default.xml. So that's what the cascade classifier I'm working on now. Execute it. Perfect. Now what I want to do is that let's apply this cascade classifier to our faces and let's see what you're going to get here. But remember, we can't directly apply the cascade classifier to our image directly. What you need to do is that we need to convert that image into grayscale, and then we need to apply it to the cascade classifier to get the bounding boxes. So what we will do is step 1 in face detection is convert image into grayscale. So gray equal to CV2 dot convert color. Now the source, but nothing but the image is img, and now what I want to do is that let me specify the color space CV2 underscore color underscore BGR to gray. That's what I want to do here. Then the next step is apply this grayscale image to my face cascade. Step 2, apply grayscale image to cascade classifier. Now face cascade dot, and what I want to do here is that we have the 3 different options are there: detect multiscale, detect multiscale 2, and detect multiscale 3. What I'm going to do in this case is that I'm going to select detect multiscale 2. And detect multiscale 2 basically will return you the 2 arguments. One is object and second one is number of detections. Before that, understanding the object and number of detection, let's see the input for the detect multiscale 2. Here what we need to do is that we need to provide the image to which image I want to extract the face, and the scale factor, minimum neighbors, flags, min size and max size. Number of detections basically refer to the minimum number of neighbors, means number of neighbors that was detected, that was referred to the min neighbors. At the moment, let me take it as a default. Now what I'm going to do is that let me take only the image which is my grayscale, and here the input for this is my boxes, which actually the object what you're going to get here is the boxes, and next is detections. Let's execute it. Perfect. Now let me print box, and what you can see here is that we have the 4 rows. This 4 rows actually indicates that we have the 4 faces. And let me also look into the detections here. If you look into the detections, what this says is that this image has 35 neighbors has been detected, and this box of portion has only 4 neighbors are detected, and this box of portion has detected 37, whereas this box is detected 10. So what I want to do here is that actually we need to set some threshold while doing this process, that is minimum number of neighbors. Generally the minimum number of neighbors people will usually select is any number greater than 6. So what I'm going to do is that let me select some minimum neighbors that's going to be equal to some number. Let me take 8 here. Now let's execute that, and here you go, we can see only the 3 boxes are being detected, and the number of detections what we have is 35, 37 and 10. So this is really cool now, right? Okay, now let's try to understand what is actually this box is giving you here. The meaning of these boxes is 321 and 84. These 2 values represent the XY position, and this represent width of the box and height of the box. More precisely, this is the width of the face and height of the face. That's what we have here. And similarly, this represents XY position, width of the face and height of the face. Now we know we have X position, we have Y position, we have W and H. And what we need to do is that we just need to simply draw the bounding box. Nothing but rectangle. We know how to draw the rectangle, right? Now what I will do is that let's write some code and do some rectangle here. Okay, so I will write down here only this is my step number 3 is actually we are trying to do the rectangle box, means drawing bounding box. That's what we're going to do here. Okay, in order to draw the bounding box, what we have to do is that we need to take the XY position and width and height here. So for that, what we'll do, for X, Y, W, H in box. So basically I'm doing in a loop. Now let me print my XY position of all these things, X, Y, W, H. Here you go, we have X, Y, W and H. Now let me use a cv2.rectangle and draw the bounding box on top of the face. cv2.rectangle, and here I just need to provide the image name, to which image I just want to draw the bounding box, which is nothing but image. Generally it's a good idea to copy the image here. So what I will do here is I will take one image saying like img, and that's going to equal to img.copy. It's a good idea to copy the image. Now let's take this image and pass it to it. Since I'm drawing something in the images, I don't want to disturb my original image. That's the reason I'm taking the duplicate image. In the duplicate image, I'm drawing it. Okay, what is my point 1 and point 2? Point 1 and point 2 is X, Y, and the point 2 is X plus W, Y plus H. These are the two diagonal points for a rectangle. Next, the color I just want to do is, let me take green color, 0, 255, 0. With that, I can able to get the green color, and then the thickness is going to be equal to 1. That's it. So with that, what I can do is that I can able to get the rectangle. Let me do one thing. Let me display this. So with that, cv2.weight key, mshow. Now this is my face detection, and the image which contains the faces is image. Now let me provide the weight key, set the value to 0, and cv2.destroy all windows. Now execute it. Perfect. You can see that we have detected the face, and what we did, what are the face we have detected, we draw the bounding box on top of this. Awesome, right? This is how the face detection is going to work using Viola-Jones algorithm, popularly known as Haar cascade classifier. Okay, let me close this by press any button, escape. Now what I'm going to do here is that instead of writing something in this way, let me write the function here. So the meaning of that is def, and I just want to write the function, name it as face detection. So just taking the face detection, and the input for that is I just want to give the image, and then the output, what I'm going to get from this is img. That's what I'm going to get here, return img. So that's it, that's what we're going to get here. So let me delete this and execute it. Perfect. So let me delete all these things which is not required for me anymore. Now let's see, like, what exactly we're going to get here. So this is what my img detect equal to. Now let me test this with the face detection, and input for that is img. Now let me show that, cv2.mshow, and this is what my face detect, and the array is img.detect. Now cv2.weight key of 0, and cv2.destroy all windows. Now execute it. Here we go, obviously we got the same thing, but still what I can able to say is that this is the good way of writing, like whenever we have the functions. So this is usually apply to our images. That will be really helpful. In the next lesson, we will see one more project on applying the face detection to our videos. Until then, happy learning.